This video is a quick introduction to confidence intervals. We'll have more specific videos for confidence intervals for proportions and confidence intervals for sample means coming up later. So again, this is just a quick introduction about what a confidence interval is and some of the terminology that you use for confidence intervals. So just the definition of a confidence interval to start with. It's a range of values that estimates the actual population value. So when you take a sample, you are not sure, in a lot of cases, what the actual population mean might be. So you can estimate, so your range will be some low value to some high value. And you expect that the population parameter, if it's a proportion or a mean, is in the confidence interval. And it's not necessarily in the confidence interval. It'll depend on the confidence level that you choose, and we will get to that in just a second. So the center is your sample mean, which would be x bar, or sample proportion, which is p with a pointy hat. We call that p hat. So that's going to be the center, or the middle, so that would end up right in the middle, and that's used to calculate the confidence interval. And the other part that you need to calculate a confidence interval is called the margin of error, and you may have heard of margin of error. They use it a lot for reporting polls, like if they're tracking voting or something like that in politics, they'll report a margin of error with their percentages. The way that you calculate a confidence interval, and I'm going to use CI for confidence interval. If we're doing one for proportions, we would take the sample proportion, and we use the notation plus or minus a margin of error. And if we were to write that out in a different format, our low number would be the sample proportion minus the margin of error. So that's our low number. Our high number would be the sample proportion plus a margin of error. That's our high number. If you're doing one for means, you would have the sample mean plus or minus the margin of error. And if you work that out, the sample mean minus the margin of error would be the low number, and the sample mean plus the margin of error is the high number. So that's the format that we're going to use for confidence intervals. You can either just leave it as the plus or minus e part, or write it out in parentheses for the low and high numbers. The margin of error, when you go to calculate that, or you need to use a certain confidence level, and that's going to depend on the value of alpha that you choose. And it'll also include the sample size. So remember, the bigger your sample size, the more confident you can be. So that's going to affect your confidence level. And I have a table here. These are confidence levels, and then you'll need a critical Z to calculate a margin of error. And that's why we need alpha to be chosen first. So these are some common ones: confidence levels of 0.9 all the way up to 0.995. The more confident you are, the bigger your confidence interval is going to be. So I'm just going to represent that here. A lower confidence level has a smaller range. The more confident you want to be, the wider the range of the values in your confidence interval needs to be. because then you're more confident that the population mean is actually in here somewhere. you'd be less confident that the population mean is in this one somewhere because it's a smaller range. So again, the higher the confidence level, the wider the range of values you're going to be, so that you can be more confident that the population mean is in that range. All confidence intervals are two-tailed because they're symmetrical. There's a mean in the middle, and then you go down and up from their equal distances, which is the margin of error. And then we have critical values of z right here. I would recommend memorizing these. You're going to use them over and over again. You'll probably end up just learning what they are because of doing practice problems. You'll see these numbers over and over. So we'll go down and look at a couple examples. Let's not lose that. Okay. So the first one, the critical value of z for a 99% confidence interval. For a 99% confidence interval, we're going to go up to this confidence level, and 99% is the same as 0.99. So we are right here in our table, and we just follow that all the way across, and our critical value of z is 2.575. So when you're using common confidence levels, it's easiest just to look it up in the table, or again, if you remember some of these values, that makes it easy too. 98%, you'll see that one's not on the table. So 98% is not a common confidence level, but we can still figure out what z will be. So 98%, remember all confidence intervals are two-tailed. And if we want to be 98% confident that the sample mean is, or that the population mean is between two things, we want an area of 98% in the middle. That leaves 1% for this side and 1% for this side, because again it's symmetrical. So 1% on each end, and let's do the positive z-score, because all the critical values of z are going to be positive. So we are interested in this number, z. If there's 1% to the right of it, that means there must be 99% to the right, or to the left of it. So the area to the left of z is 0.99. So we could punch that into our calculator at the inverse normal function. We're in the z distribution, so we have a mean of 0 and standard deviation of 1. And we get 2.33. You could do the same thing with this one, just the area to the right would be 0.05. So if you ever can't find a z-score on a table, or if you don't have your table handy, you can always do it this way. So if the total area is 1%, now this is going to be 0.005 over here. That would be 0.5%. So over here you'd have 0.995. So you could do your inverse normal, 0.99501, and you'd get the same number that's on the table for a critical z for 99%. So that's a number that you'll need in order to calculate the margin of error. And again, a lot of them will be just using common values for the confidence levels, so you can just look it up on the table. Okay. So what does a confidence level or confidence interval mean? A confidence interval, the percentage of that tells you how confident you can be that the population mean is actually in a confidence interval that you calculate. So if you have calculated a particular confidence interval, so we have a confidence interval that goes from some low number to some high number. If we did that with a confidence level of 95%, or 0.95, we can say that if we did this over and over again and took lots of samples and calculated a confidence interval for each sample, 95% of all the confidence intervals that we made using those samples would contain the population parameter, which is a mean or proportion. The more common phrase that we use to interpret confidence interval is that we can be 95% confident that the population parameter is within a particular confidence interval. So typically we only take one sample and calculate one confidence interval, and we can say that we're 95% confident that the population parameter is within that one particular confidence interval that we calculated. What you should not say is that there's a certain chance that a population parameter is within a particular confidence interval, because the population parameter doesn't change. It's a constant value, so it either is in your confidence interval or it is not in your confidence interval. So the probabilities are either 100% or 0%. You can't say that there's a 95% probability that that value is in your confidence interval. You can only say that you're 95% confident that the population parameter is in your confidence interval.